our third international workshop on RF and microwave components. So today we have with us Deepak sir. He is a senior application engineer in CST for Jyoti Electronics. So today he'll be talking on how we can use for CST for different design purposes. Mostly he'll be talking on design of circular patch antenna using CST Microwave Studio. So on behalf of VIT AP University and from all the participants, we welcome you, sir. And now we kindly request you to start the session.
Thank you, sir. Okay, let's start the session. I'm Deepak Shekhawat from Jyoti Electronics. Today we are going to give you a brief overview about the CST, what kind of capabilities CST have, and some short exercise for the circular patch antenna. So, so my screen is visible.
Visible, sir. Visible.
Okay. So everyone knows our topic is CST. So what is the CST? How we can use this CST software for the EM simulation. So let's start. So we are Jyoti Electronics, a techno trading house based in India, in Ahmedabad. We are dealing in the electromagnetic software since last 35 years. We provide various simulation tools.
Sir, you
Uh,
have shared any presentation?
yes, I shared an
We are not, no, we are able to see your screen, but
but not
presentation we are,
okay.
presentation we are not able to see.
Okay, one moment. Now screen is visible.
Yes, yes. Can you please make it full screen, sir?
Yeah.
Oh, yeah. Okay, good.
So we are going to give an overview about the CST, how it is useful for the EM simulations. So we are Jyoti Electronics based in Ahmedabad. We are dealing in various kind of software for simulations of EM simulation tools, antenna design tools, circuit simulation tools. So this is our principal CST, Ready Take, and RNS, various kind of hardware components related to the microwave components. RS we provide that. We also provide some simulation from Simula Abacus, like Simula Abacus. These are our customers, ISRO, SAC, DRDO, almost all NIITs, NITs. Those are dealing with the electromagnetic designing of the electromagnetic components. These are our customers. So today we are discuss about what is the CSS Studio, what is the Spark 3D, what is FS 3D, antenna Vegas, and all that. So first of all, Spark 3D. Spark 3D is software where we can calculate the RF breakdown power for any kind of passive devices, which includes cavities, waveguides, and antennas. After that, we can import the CST result into directly in Spark 3D to analyze what breakdown power or multifactor. So this is the capabilities of the Spark 3D software. Next, S3D is a very fast software. It is capable to analyze complex massive microwave components in extremely short times. It's accurate analysis of passive components based on the waveguide technology. Next one is the antenna maker. It's already provided you 350 antenna weights. So if you want to design any kind of antenna, most probably there is a model available in this library of antenna. It accelerates your designing process of antenna. So initial levels you can estimate the performance of any kind of antenna in antenna maker, then export to the CST microwave. So this is the Opera. This is suitable for the low frequency kind of devices or applications. We can analyze electromagnetic simulation, electromechanical systems in 3D or 2D dimensions. Now this is the abacus. This deal with the mechanical part of the problem. If you want to design any kind of complex linear, if you want to do for the linear non-linear analysis of input for the geometry material, we can perform these kind of simulation into the abacus. So what is CST? CST used in various kind of industry like communication industry, defense industry, in order to analyze the optimized performance, reliability, and electromagnetic compatibility of single and power industry. It's also offers a spectrum from statics up to optical frequency. This is the CST product portfolio. As we already discussed about, we already gave you a brief overview about all these portfolio products, CST Studio, Antenna Mega. Filter Design 3D is a specific tool to design microwave filters, Fast 3D, Spark 3D, and chip interface. This is and system simulator. You can design whole system into the system using the system simulators. These are some examples for the CST microwave studio. We can design antenna, planar device, flatter, filters, resonators, and helix type of antenna. In CST EM studio, you can design port magnet, high voltage insulators, RJ45 connectors. You can design any this. You can design anything, break like a generators, motors. On the study of the magnetrons and electron gun, if you want to study about the what is the movement of the electron, what kind of velocity it takes, so you use the CST particle study. It is a fast and accurate analysis of charged particle dynamics in 3D electromagnetic fields. When it's an physics, when you want to analyze the thermal and mechanical structure problems.
Hello, sir.
Yes,
Excuse me,
yes, sir.
sir. Your voice is very low, actually. So participants are also saying that your voice is low. So
Okay.
can you?
Now my voice is sufficient or
Yeah,
audible? Loud enough?
yeah, yeah. Now it is audible.
Okay. Now CST M physics study is used to analyze the thermal and mechanical structure problem. In this, you can design what kind of deformation occurred due to the ambient temperature effect, or what kind of environmental effect on some kind of on
Sir,
some kind.
hello. Excuse me, sir.
Yes,
Sir, still,
yes.
still the voice is very low. Actually, still the voice is low, and some background noise is coming.
Okay. Okay. Just wait for 5 minutes. I will
Okay,
come
okay,
with the another.
okay.
Sir, can you hide this ribbon also? Ribbon?
Which ribbon, sir? Your
It's visible on the screen. That if you just click the hide button, it will just vanish. Okay, now the screen is gone actually.
yeah. Now the sharing of the screen
gone.
is.
Yeah.
Yeah, all the dear participants. So please switch off your video and please unmute. Some of you are actually showing your video also. So all the participants, so please wait for 2-3 minutes. So the speaker is actually trying to fix the his audio problems. So there is a problem with the audio. So he's trying to fix it. So please, you can wait for some 2-3 minutes so that he will come with the solution.
My voice is audible, sir, now?
Yes, sir.
Yes, sir, it is audible.
And the slides?
Yeah, we can see.
Okay.
We can see.
So this is our last slide where we talk about the CST multiphysics studio where we can study about and if you want to study about any kind of thermal deformation in any kind of problem, we go with the CST MEM physics studio. The next one is the CST design studio. In this, you can design all complex system into the CST design studio and analyze the various kind of results. These are the some examples. So if you want to study about the PCB, any kind of PCB to about the SI and the PI of the EMC and EMI simulation for the PCB, we go with the CST PCB Studio. So this is the CST cable studio where you can analyze the what kind of crosstalk is available, crosstalk, and in coaxial cable we can analyze using the CST cable studio. This is dedicated to for the analysis purpose of the cables. So there are two types of solvers available in CST. First one is the general purpose solvers. These are there is two solvers is there. First one is the transit solver. Second one is the frequency domain solver. So according to your problem, what kind of problems you have related to the when we talk about the size of that problem, electrical size. According to that, we classified on which kind of solvers we are going to use, what kind of behavior shows by these kind of your problem, what kind of resonancy shows by your problem. There are various criteria which we analyze before selecting the and which solver is suitable for that kind of problem. If you want to analyze electrically medium and large size problem, you go with the transit solver. If you want to study the strongly resonant structure, then we go with the eigenmode solvers. If you want to do the RCS calculation, we go with the asymptotic solvers. If you want to analyze narrow band kind of problems, then we go with the frequency domain solvers. So according to these criteria, we select which kind of solvers is suitable for which kind of problem. So in designing of antenna, most probably 90 more than 90% cases, time domain solvers and the frequency domain solvers is suitable for most of antennas problem. So these are the some parameters. These are the main parameters which affect the accuracy of the solvers. The electrical size. Electrical size means electrical size. If your problem size is greater than 40 lambda, then we can say it is a medium to large size problem. If what kind of materials you use is also affect the accuracy of your solvers. What kind of resonant behavior shown by your problem. What kind of type. What kind of meshing you want to use and what kind of acceleration methods available with you. There are multiple acceleration methods supported by the CST. So in CST, we have three types of mesh: hexahedral mesh, tetrahedral mesh, and surface mesh. All meshes are supported by the various solvers like hexahedral mesh supported by the transit solvers and tetrahedral mesh supported by the frequency domain solvers and eigenmodal solvers. You can change these types, which kind of mesh you want to use by using the drop down menu in the global mesh, global properties. So this is the some help mechanism available in CST. These all PDF files available in every system which have which in if that system has CST. You can access this PDF file by going to the program files, then go to the CST.
Hello, Deepak sir. Can you hear me? Hello, Deepak sir.
Sir, any problem with the audio or what?
Yes, sir. The audio is not visible, and I cannot see the screen as well. Audio.
ఇంకా రాలేదాకా వస్తారు.
Deepak sir. Hello, Deepak sir. Can you hear me? Hello. Deepak sir, is there an issue with the audio? Deepak sir. So all the participants, so please wait for some time. I think there is some issue. So we are calling the Deepak sir. So we will start the session soon. We are contacting him. So at least can you all hear my voice?
Yes, sir.
Okay. So let us see. So we are contacting him. So we'll figure it out actually what is happening there.
Hello, participants. Actually, there is some internet issue from the expert side. Please wait for 5 minutes, and we will be continuing the session.
Yeah, now I think he is back.
Sorry, we are facing some technical issues. Right now, can you tell me which slide I am last time at what slide I'm?
So now you're yeah, this slide. So last time you were displaying this slide.
Okay.
Uh,
Can we resume?
yeah, we can resume.
Okay. My voice is not loud enough?
Yeah, it is loud.
Okay. So these are the mesh types available in CST: hexahedral mesh, tetrahedral mesh, and surface mesh. The particular what every software solver is dedicated for a specific kind of mesh. You can change this type, which kind of mesh you want to use using the drop down menu in global properties. So this is the next option. What kind of help is available with the CST? Every system, if CST is present in that system, you can find these documents in that system in C drive. Go to the CST studio, any version that's not related to the specific kind of any version. If you are using 2021, 2023, any version, go to the documentation. You file these PDF in your system. Every file consists with one example, one workflow with the particular exercise. You can go with that exercise. Most of the concept you are able to clear, and any kind of problem if you are facing, then this will be helpful. So this is the next part: component library. A very good library available with CST. Like if you want to search antenna, these various options are available, like patch antennas with frequency domains. You can analyze, you can go with the step by step procedure. You can see the results in component library for these available examples. So one more helpline section is in every pop-up window. Help options is available. In particular, that pop-up window, any mention option, detail of every mention option is available in that particular help section. So next is ES simulation workflow. What first of all we have some kind of ideas, then we create some virtual prototype according to your problems. You define what kind of solvers you want to choose and define various kind of settings. What kind of boundary conditions you want to choose, when which frequency is you are analyzing your problem. Then finally you analyze the results after the simulations. So this is a project template which when you use CST, you are able to see that there is 5 application domain is available: microwave and RF and opticals, EDA, electrostatics, statics, and low frequency. According to your need, you select one application area. Then according to application area, various kind of options available. This will create a template for your project, your problem. So this is the graphical user interface. When you start with the CST, you are able to see that first of all is ribbon bar, where various options are available related to the modeling of the design, related to the simulations, post-processing results. And B is the parameter list, which I always recommended to use. Parameter list, you are able to define a parameter list with the expression or with the values to define your geometries. If you define these parameters into your parameter list, then you are able to use the parameter sweep option and optimizer option in CST, which is a very good tool for to design or to optimize your problem, your task. So next is the C is the progress windows and the message windows. Various kind of, if some kind of error occurred or some kind of warning occurs, you are able to see in the progress window and the message window. Result navigator is used to see according to when you go with the parameter sweep option. The various steps are there to find out the results navigator, and navigation tree is to monitor the every steps of your designing. You are able to find what kind of component is there, what kind of solids you define, what kind of material is you define, what is the property of that particular materials, how many ports you define, what kind of monitors deployed to study various kind of electric field, various and any kind of fields or other very and other things. So these are the primitives available with the CST: spherical shapes, brick shapes, elliptical shapes, cylinder shapes. We are going to use brick and cylindrical shapes for our small workshop hands-on exercise for the patch antenna. These are the different view option which we are able to see the various kind of view when you want to design a complex geometry. These are very useful things. by using these kind of different view option, you rectify your complex geometry. This is the show and hide shapes option available with CST. When there is a number of your components is very large, this option is very useful by hiding some unusual or by hiding some other components in some on you. If you want to work on particular object or particular uh, problem, then hide the other things and work on that particular geometry. This is very useful for the complex design. So next is the pick option. We are going to use this in our exercise. This is the pick. First one is the pick point, pick age, and the pick face to align W working coordinate system. We always recommend to use these points, edges, and face by double clicking or not entering the coordinates value. You can do it, but we always recommend for the double click, use the double click option. This is useful when we design complex structure. This is the working coordinate system. We there is one option is there we can change our coordinate system. This is local working coordinate system to local coordinate system by using the picking points. When we first point shows the align the working coordinate system with the point by using the pick option, we select the point and we align the WCS with the point. In second option, we can see that we by using the pick option, we select the edge and align our WCS with the edge, and in the third with the face. So this is two another options which we can use for the transform of the our coordinate system. The first one is the move and the rotation, translation and the rotation. You can shift your coordinate system, local coordinate system to some distance if you want to. You can rotate your local coordinate system. I'm using two different words: local coordinate system and working coordinate systems. So next one is the Boolean operation. When you want to add, subtract, or intersect options, these options are available with the CST. So this is useful for when designing of the various kind of geometries. So third, next one is the curve modeling tools. When you want to design some structure using the 2D structure to from 3D, these curves are useful in that scenario. So extrude curve, planar curve, and the sweep curves options are available for the designing of the complex geometry. These are the some example. We are going to use extrude curve option for our designing purpose. These are the some blend and chamfer edges option to if you want to chamfer the particular edge with the chamfer width and angle, you can use this. If you want to blend your edge, then enter the radius value and use go with the blend option. These are the other options for the translate, scale, and rotate. So there are so many options are available with the geometrical for the designing of any kind of geometry. This is the shell operation. When you want to create a waveguide structure, this is very helpful when you want to design some horn antenna or circular or a pipe kind of structure, hollow pipe structure. Then this is the useful operation as shell operation. By selecting the both faces, just perform the shell operation. It will create a one shallow structure. This is a loft operation when you want to join two faces of two different objects. When you want to join a face of circular disk to a one cubical disk, just go with the pick loft operation. It will automatically connect these two faces of the different kind of geometry. Another one is the bending. When you want to design when you want to bend a sheet on some particular curve structure or some you want to prepare some helix structure, then this option is very useful. If you want to bend a sheet on to some other curve shape, this option is useful. So two types of ports available in the CST. First one is the discrete ports and the second one is the waveguide ports. Waveguide ports is useful or provide you better accuracy for the S parameters results, and a discrete port can be also used for the TM modes, not for the other higher modes. So there are three types of ports available in discrete for the discrete ports: S parameters, current parameters, and the voltage. So defining any kind of a discrete ports, we need to define. We have to pick 2 points, either 2 points, either 1 point, or a phase. By selecting these points, you can create the wave, discrete edge port. There is other option is also there, ki defining the coordinates. You can also create the port, but we recommend it for the pick use the pick option. You can also define discrete port by using the two edges or one edge and one face. So to define a discrete port, you have to select two things: 1.1, 2 points, either 1.1 face or two edges, one edge, one face. So this is the for the waveguide port structure. The port size is equal to the smallest rectangular area, which includes all projects. For the waveguide, just selecting by using the pick face option, you can select these by picking you are selecting any kind of points, or by two edges you can create the waveguide port. We will show this example. But I personally recommend it for this macro available to define a waveguide ports. Macro is automatically macro is available in CST. Yes, sir. Just go to this macro option, go to select the solvers, ports, and calculate port extension coefficient. This macro automatically calculate the extension coefficient and calculate the waveguide port your particular selected microstrip line. So no need to worried about the calculation of the extension coefficient and enter the coordinate value in the just like in previous slides. Just choose this, use this macro for defining the waveguide port. So this is the result handling part of the CST. The three types of results available in CST. First one is the standard results. These results computed automatically for every simulation, and the available for the every kind of simulation. And second part is the results monitor, where you have to define what kind of monitors you want to install for particular frequency or for a band of the frequency. You can use that. The third one is the result templates. On the basis of the our standard results and the result second type of results monitors, you can compute the third types. You can calculate the other parameters you want to calculate by using the post processing template. You can use VB programming as well. To if some options is not available, you want to define any particular kind of your results by using some S parameters. So if you want to calculate some other new parameters, then by using the VB or Python, you can create your own result templates and calculate that thing. So these are the some example for the 1D plots which is available in CST. You can it's look like that. There is a curve marker option is available, measure line option is available, axis marker options is available. So these are the 1D plots of Smith chart where you can calculate the impedance and the admittance of any kind of for the antennas for the AM analysis. These are the few examples for the 2D and the 3D results where you can see the surface current and the electric field. These are the some far field results. These are the some post processing results. Now, one important option is parameter sweep overview. Just take a one. We are taking a one height. We are not able to. We are not. We want to analyze the for we take a one waveguide with the W and H. We are not able to. We are not sure what is the optimum height for the your waveguide. Just define a H parameter into parameter list and use the parameter shape option. In the range which you define, it automatically calculate the do perform the simulation for every edge and store the results. Just analyze your results and find which is the suitable edge for your design. So we are going to how we can use, but just by selecting creating the new sequence, you have to define which parameters you want to vary, or W or H. Like in this example, we just define the value from the for the length. In particular slide, we want to move from 21,169. You can define in what range you want to define your length, or what kind of what kind of types you want to define for the sample size at what time. Various options is available. Linear sweep if you want to perform what kind of number of samples you want to define, or you want to define a step width, you can define in that sequence. First decide. This is the example for the 1.24, 1.48. In sequence, just define the parameters in which range you want to perform the simulation. If you want to define a number of samples, you can define number of samples. If you want to define a step width for the particular range, you can define the step width for that particular range. It automatically create for the entire range of the results for particular selected parameters. Just like in this example, we simulate results for the offset value for 1.48 and 1.24. So you are able to visualize all results. If you define 10 samples, it create 10 graphs for every defined values. So next one is the optimizer overview. According to this is the overview for the optimizer. First you have to you have to set up the optimizer parameter. You have to define the goals. You have to select which parameters you want to change. After monitoring process, you are able to decide which results is good for you. So just these are the two ways which you are able to access this optimizer option by going to the solver settings, and or next is the solve. But in the ribbon bar you find the solve and where you can find the optimize. This is the result for the before the optimization in the red one, S11 before, S11 after is the after the using the optimizer option. So first, in for particular design, we select the two parameters x1 and the y1 in the range of -10 to 10 for both, and we select both in both parameters. And with the next step, we define the goal function. Ki what is the our need? We want our goal is to decrease the value from S11 below the -20. So we define the goal, add new goal. We define the S11 what values for the our goal like this. By using this operator, we define the value for the s, and after defining the goal function, we decide which kind of algorithm you want to use, various kind of algorithm which available in CST. If you want to define your own algorithm, you can define also. So if your results, initially results are good, then go with the trust region framework, or if your initial results are not up to the mark, then you will go with the CM evaluation strategy. According to uh, selected algorithm, optimizer perform the simulation. It automatically calculate the various values for the different parameters and select and shows the only best results. So this is the monitor progress where you can find the, for a particular step what kind of results are occurring that in the parameter values, in the goal values, and then the S parameters values. So these are the some example which we like to show that particular for the patch antennas. These are the result for particular patch antennas, S parameters results, and the VSWR results which we get from the simulation, CST simulation. This is the far field results pattern in CST for the particular frequency of 4.9, where or with the gain of 6.891 dB. This is the design for the horn antenna design, and these are the results for the horn, this particular horn antenna design. This is the 3D types of one example of 3D results. Array task is also available with the CST. So we can design array with some steps. Like if you want to design an array of any antenna, just go with the simulation project and click on the array task. By giving the what kind of shape you want to create for the your array, and what is the side, what number of elements, or what is the spacing you want to use in your particular for the your array task. Just enter the values and create your array by selecting the mirror selection. By following these steps, you can create your array task. These are the some excitation pattern available in the CST. First, we are showing some Taylor excitation pattern for your array. We already defined the relative side level for the -30 dB. We also create by performing unit cell simulation. We these are the steps for the unit cell simulation. You can define the various scan angle for the unit cell simulation. You can define value of 5 from 0 to 90, or in according to your need, or with this step it you can define anything. These are the boundary condition available with the CST for the particular array task. We defined unit cell as the array direction, a boundary condition for the x-min and the x-min in the y-min and the y-max are all defined electric ET0 in the z-min direction. So performing this is the flow gate code properties for the excitation for the array task. We can use these. These are the some example for the microstrip antenna for multiple ports, 8 by 8, 8 cross 8 array, and the result for the particular antenna array. This is the result for the unit cell simulation, 1D results, 2D results, and the polar code results. 4 by 4 array excitation, Taylor excitation pattern. Results for the that particular array in the 2D form, 1D form. So I'm showing some results for your reference. The 1D results, 2D results for 4 by 4 array, 12 by 12 array, and the uh, 16 by 16 array. So you can cross and cross an array with using the CST, and you analyze what kind of results you get on the simulation of that particular array, or 1D form and 2D form. You can analyze anything. So there are different feeding techniques also there in antenna. You can see the results for different kind of feeding techniques. This is a result for the microstrip patch antenna results in 1D form and 2D form, 3D form. You can see the animation, what kind of electric field you can see. This is for the multiple ports. You are able to analyze the electric field, how it's work. So those are the results for the multiple ports. These are the different techniques. So we are able to calculate and analyze the whole antenna with a different kind of feeding techniques. These are the some simulation of part of the 3D results, 1D results. So these are the some example for the your different kind of antennas, different kind of antenna techniques in 1D form, in 2D form, and 3D forms. You can analyze the spectrum also. You can analyze the 2D pattern also, 3D pattern also for various kind of antennas. So if you have any queries, please ask regarding the CST software overview. Hello.
So all the participants may note down the mail ID of the Deepak sir, so that you can contact him later.
If
If
you
you
are
have any doubts,
if you have any kind of problem related to antenna designing or any microwave component designing using CST, you can write on us.
Sir, I have one doubt. Should I ask?
Yes, sir. Yes, sir.
yeah, you can proceed.
You have shown the array of planar array. Can we change the beam steering angle to focus a particular direction?
We can define various angles, sir. I think one slide is there.
How we can do it?
By entering the different kind of values, sir. You want to change the scan angle, na?
Yeah.
So may I know your name, sir?
Myself, Dr. Dhade from Nagpur. We have a CST software in our college, YTC. So we have talked earlier also.
Okay.
CST Studio, we have purchased the software in our college.
Okay.
And we have to not yet explore if you want to make the beam steering.
Okay, beam steering.
To focus the beam in a certain direction. For example, we are taking the radiation pattern. It is broadside of the patch. But if you want to change the tilt, how you can?
Sir, I right now I'll want to say that, sir, just I'm not able to clear your problem. So can you write your problem and mail to us so we can share a workflow regarding your problem. So it will be more helpful for you.
Okay.
Just share your details, your email ID and your number with us. We will contact with.
Okay, absolutely. Thank you.
Sir, your name is
Myself, Dr. Prasanna Dhade.
Dr. Prasanna.
I
Okay.
am in Yashwantha Chavan College of Engineering, Nagpur.
Okay.
We already discussed once or twice earlier, means it is a few years before,
Okay. Okay.
around 6 years before, we discussed regarding by purchasing the software from you.
Okay, sir. We try to just write us on this email. Support that we will contact. Hello.
Huh, sir. No problem. No. I will
Okay,
write
sir.
a mail.
Yes, sir. Thank you, sir.
Hello.
Yes, sir.
Sir, I have a question. Can we feed array of antenna using single feeding technique?
Yes, sir.
That means using a single port.
Using a single port. So we can decide. We can excite by we can select various kind of excitation. What kind of techniques you want to use?
Yeah, but it is a array of antenna, na? So using
sir.
single port, can we feed it?
Using single port.
Or we have to use multiple port?
So give me one moment.
Yeah, good morning. I'm audible. Yeah, this is Pankaj Chawla, Senior Application Engineer, CST Jyoti Microsystem, hailing from IIT Jammu. Yeah. What's your question?
Sir, question is array of antenna, can we feed it using a single port?
Array of antenna?
Can we feed it using a single port?
Okay.
Or we need to use a multiple port?
It
Multiple
depends
feeding.
upon, it depends upon to your particular application. If you want to deploy the phased array antenna, okay, with different ports, if you require to add the phase into that way, and by the way, into that way, you can add the beam stability or the beam forming. You can do with the multiple ports as well. But if you do want to do with that single port, you can do that even by adding the phase shifters into that way. Okay, by adding the phase shifters into the particular traversing or particular stubs into the stubs, if you want to deploy it, you can go into that way. It solely depends upon your application sort. What by the way, what are your applications, like in what sort of applications you want to deploy into that?
No, it's my general question, sir.
Okay, yeah, you can do that. You can do that. You can either you can make what we can say a center fed or an end fed. Okay, there are two types of feeding as well if you want to classify. Okay, either you can fed the antenna from the center and make a whole array to be get excited. Okay, or either you can just excite your antenna array from the end. Okay, you make an end either with the strip feeding or either with the coax feeding. Okay, you just can deploy that and do whatever the application you want to deploy. Even when I was at DRDO, there was a lot of arrays were going on. Okay, it's little confidential into way, but you can classify these way as well.
Okay, sir. Okay, thank you.
Yeah. Any other questions from you?
Sir, I am having one doubt.
Yeah, go ahead.
Sir, actually, for optimization of post-processing setting, in that we have the general 1D, no, sir, in template-based post-processing.
Okay.
In that, I am not getting the cross-section and total ACS, sir. For that, I need to optimize the antenna. How can I get it, sir, in that general 1D results?
Like what thing you want to optimize? Which parameter? I'm not getting into that way. Can you elaborate into that way?
Total cross-section, sir. Like
Total
in
cross section.
2015.
Okay.
Yes, sir. Total cross
So
section.
you can make
In 2000.
like if you want to vary your cross section. Okay. So what sort of geometry is it? Either it would be a rectangular or cubical or circular. What sort of geometry or non-Euclidean?
Rectangular only, sir. Rectangular only,
Okay.
sir.
So you can do one thing. If you want to optimize your cross section, you can make two variables. Length has a variable and breadth has a variable. And if either
Okay, sir.
go for parameterization or either go for that particularly, you can go for optimizations. Okay, like different algorithms are there, like trust region framework are there, and CMA evolution strategies are there into the CST. So you can deploy these parameters into that way and go with respect to your particularly optimized particularly parameter which you want to create, whether it would be S11 to be less than 10 dB or VSWR to be less than 2 sort of.
Okay, sir.
Okay.
Sir, all the
Sir,
parameters we have to check.
sir, excuse me, sir.
What's your good name, by the way? Who asked the question?
Sir, this is Sridevi.
Okay, okay, Shri Devi. Please go on.
Uh,
Yeah.
Sir, for a circular array, can you feed at a single point, sir, not individual feed? Can we feed a single point for a circular type of array?
Okay.
How
You
we
can,
can, sir? How we can?
yeah, you can create the, but at the edges you need to circular one of that particularly what we can say tangent angles. You can have to add the strips downway in order to particularly couple two or three particular array patches, antenna patches into that way. Okay, just see the literature if this if there are literature onto that way, because in
But in,
rectangular there is lot of, yeah, in rectangular there is lot of literature where you can feed at the center and it will just feed to the whole particular geometry down here.
yes,
Okay.
sir. Lot of
Yeah.
literature is available on the rectangular, but on the circular, we don't have for feeding at a single point. So that's why I'm
Yeah,
asking.
circular, you can also go with that and check whatever the results you're actually getting. Are there at the optimized level? You can deploy that and in your particular labs down way. But you have to just see what would be that directivity it would provide to you. Either it would be near to 6 dB or 8 dB, so it would be sufficient down way. But directivity, if it is providing a low thing, then you have to just do it some other optimizations into that way. Okay. So you need to understand certain parameters like whatever the S11 it is providing to you. If you're providing it through a single particular thing, it can serve your purpose, I believe down. Just do that. Make even you need to excite, must need to couple two or three particular antennas using some strips or particular downway. So it would be that particularly directivity and coupling factors come into the picture downway as well for you if you go with that.
Okay, sir.
Yeah. Any other queries?
Any other queries you can ask the you can ask. Any other queries? Sir, myself, I'm Dr. Bharat. So I have one query. Actually, do we have any machine learning kind of tool available in the CST now?
Okay, you want to deploy ML into that way. You can go into that way as well. Like for instance, you can just take that particular data because ML is what you have some data sets. You provide the what sort of learning you want to deploy, whether it would be a supervised learning, unsupervised learning you need to deploy, or some algorithms like bag propagations, and so you want to deploy. Just took the data of like for instance took the S11 parameters down with the values and different particular magnitudes and phases and different points sort of, okay, different frequencies, and just take their data set and deploy into your particularly AI and particular ML particular convocation what we can say convolutional particular networks down way and get your results what do you want to optimize. You can add into that way. You can extract the data set from the CST actually and put into any sort of network, these ML networks, and serve your purpose with AI down. Yeah,
No,
you
sir.
can do that.
Actually, my doubt is in the because in the CST we have optimization
Yes, yes, yes,
option
yes.
is. So similarly, I'm asking actually, do we have the inbuilt machine learning
Okay,
option?
okay, okay. You can actually interface with the MATLAB as well. We have macros in the
Oh,
CST, okay. So you
okay.
can in macros, you can interface CST with the MATLAB. And with the AI MATLAB codes, you can interface directly into that. But we have that particular interfacing capability for you. If you want to deploy the ML or particularly these ML techniques down. Okay.
Mhm.
Yeah, you
Yes.
can interface very, very easily. Just go to the macros Even if you say we'll share you that particularly, even you can share, I'll share the document of Python with you as well. You can interface CST with the Python, and putting that AI particularly into the Python, you can just take the data set from the CST and extract your machine learning capabilities with the particularly into that particularly in RF sort of. So you can go with that as well. We'll share you. I'll talk to with Mr. Deepak Shekhawatji. He will share you regarding that way. Okay.
Okay, sir. And
Yeah.
I have one more doubt.
Okay.
So because sir, can we launch the CST into a? Can we launch the simulation of the CST into a HPC?
Yeah, we have the capability of HPC. You have that. You should have the terminals which can support HPC. We have our customer at ISRO, DRDO. So we normally even BARC as well. We deployed on HPC. That we can increase the. You can actually increase the number of ports down way. Okay, if you have that capability, we are there for you always.
Okay.
Yeah,
So
for
is
sure.
sir HPC okay? And can we run the simulation? Because now if you see the MATLAB has got the online MATLAB. That means you can run the online. You can run the code online also using the MATLAB online. So do we have anything like online CST so that we can do the simulation if we don't have the powerful computer? So we can use the cloud-based service given by the CST. So is there anything kind like that?
That I will check down way and revert you if it is feasible sort of. Okay. But any technical questions if you have like onto the geometry specific radiation patterns, you can go with that as well. But that I'll revert you, not an issue. Yeah. It's a little query onto the particular cloud that I'll revert you.
Okay, so dear participants, so please, if you have any further questions, please please ask the
Hello.
questions.
Yeah,
Yes.
go.
Yeah, sir, if you have some question, can we write a mail to you?
Yeah, for sure, for sure. Just revert us at support@jyotimicrosystems.com. We'll revert you.
Okay, okay, sir. Thank you.
And name, must write your name and particular name of the college down there. Okay.
Sure, sir.
Yeah, for sure, for sure.
Any further questions from the participants?
Sir, once again, you display your slides, that email ID and other things. So
Your voice is little crumbling. Can you go into that way? Yeah.
show the slide once again, so we can note your number as well as email ID.
Okay. Yeah.
Okay. Thank you.
Yeah. Yeah. We call for the day. Thanks, huh? Thanks. Yeah. Hands-on activities there. Okay.
Can we go for the hands-on activity?
Yeah, no problem, sir. No problem.
Time permits.
Yeah. Actually, we have the time till 11:30, so you can go ahead.
Yeah.
Okay.
Yeah.
So there is a small exercise which I want to show you. Just this is a circular patch antenna which we want to create in this exercise. I think this is visual to everyone.
Yes, sir.
This is the design we want to create using the CST.
I request all the participants to mute yourself. Okay, so because Sar is presenting, so mute yourself. So we will go ahead.
I think some of them having CST or not.
Yes, sir. Some of them had, I think, they were using it.
Okay. Okay. So just how we can start with the CST. So this is the CST window, main window. We go with the new template, microwave and
Sir,
RF.
sir, you want
Yes.
them to open the CST if they have?
Yes. Yes, I want to follow them. Follow me.
Okay, okay. So if the participant had the CST and opened it, so you can actually follow it.
Okay. When everyone open CST, just inform me. Is anybody is having CST? Is anybody doing this exercise? Or everyone is aware with the CST, basic CST steps?
So any one of you have opened the CST now?
Okay, let me show you some slides which I want to perform on CST. So
Okay, sir.
if
Okay.
these are the some slides, these are the steps. So first off, this is the my circular patch antenna which I want to create on CST. I want to just show how we can use the CST for designing this circular patch antenna. The dimension for this patch antenna is 60 by 60 and the height for the ground plane is 2.1 and substrate height is 0.7, patch height is 0.07. So this is the first slide for the construction of any kind of geometry. Just go with the microwave and RF application, select the antenna, go with the planar, select the time domain solver, and this is this for the summary part of your project template. So how can do that? Just show it. Just microwave and RF antenna. Next, the planar patch antenna. Time domain. Depending upon your problem, you have to select what kind of which kind of solution you want to select. Just next, these are the dimensions already default set. If you want to enter the frequency values, you can enter or you can later on. So this part is over. So next is how you can create the how can define the new material. Just by clicking on the new material, you are able to define the new material, entering the values. Just using the brick option, we can create the substrate part of it, ground part of it, using the extrude phase. These are the steps which we are going to follow if someone is following me. These are the next steps for defining circular patch antenna. Is anybody following me? Or we can just show the PPT to how we can create that. Or you are able to see in the CST also. This option, this exercise also available in CST.
Sir, I think so. Anybody is following? Prasanna, sir.
Sir, we have already.
I am showing in the component library section. You can find the all steps in that area. I think that will be more if someone is.
Sir, I think you can go ahead with the Prasanna, sir. Want to say something? Prasanna Jade, sir.
Sir, we know
Yes, sir.
you can go ahead. I think you can show your slides and some innovative things that yet we have not explored. We will ask the question on that.
Sir, you are not audible, sir.
Unmute. Okay. Now you go ahead with whatever you want. No problem.
Okay, sir.
If I have some doubt, I will ask.
Okay, sir. Sure, sir. So this is the our second step, how to define a new material. So just go to the modeling section. There is a option, define new material. You can define any material. We are defining material for substrate. Value for the epsilon is 2.33 and mu is 1. If you want to define conductivity for your material, you can enter the values. If you want to define dispersion, thermal properties of your material, mechanics properties of material, density, multiple options are available. According to your need, you are able to define your materials. this material is already available, you can select them. If material is not available, you have to create that material. Just press on apply and OK.
I think there is a problem with the CST. It got not responding. So I think it will open. So wait for a minute. So those who are following it. So if you have any difficulty, you can stop me and you can ask for any doubt. So when he's showing the demo. Now he is sharing again. Deepak sir, can you hear me? Deepak sir, can you hear me? I think there is a problem with audio also. Let me.
Yes, sir. I think there is a problem with internet or some
Okay.
other thing.
Okay.
Now go to, we are repeating the steps for the new material. New material, just define the material according to your need. Enter the value. As we select 2.33, so we enter the values. Press OK. So now we are able to find a substrate, new material in this navigation tree. Yes. Now we are able to see the substrate new material. Okay. You can exit it, or if you want to edit it, you can edit it. There is no problem with that. So now first step is we are going to create a substrate with the dimension of 60 into 60 and the height is 0.7 with the vacuum material, with the substrate material. So just go to the brick option, press escape, define any name to your geometry. Just enter the coordinates which you want to. You want to create 60 by 60, that's why we are entering minus 30 to 30 and 0 to 0. 0 minus 0.7 to 0. You can enter anything. You can enter any value according to your understanding. If you minus 30 to 30, it means it is symmetric to origin. If you want to change it, you can change it. Minus 60 to 60, then your first corner is yeah.
Deepak sir,
Yes,
what
sir.
happened? What happened?
So, technical issues. Now CST is not responding. Now it's responding.
Okay.
Presentation, you can show your presentation directly. Take for it. Instead of doing actual, you can show it the slides.
I will show you the how you can access that.
Ah, but,
So this is the help section where you can find this every steps of designing of this antenna. So this is the dimension of our circular patch antenna. So these are the some geometric constituents step by step. Every detail is there for every kind of tutorial example available in CST Studio Library. So first of all, you have to create the new project. Am I audible, sir?
yeah.
Yes, yes, yes.
So first of all, you have to create your new project by going to antenna. Just select microwave and RF optical, then antenna. Then you have to select the planar patch antenna, time domain solvers. Then enter the dimensions for your particular geometry, and create your project then. After that, you have to create the bricks for your substrate. Just enter the minus 30 to 30, minus 30 to 30 for the 60 by 60 cross antenna, and the thickness for the 0.7. We already complete this step. We already define material, substrate material. Just by you selecting the material part, just go to select the drop down menu of material. Options are available is new material, load from the material, or predefined material which are available in your that particular template. Select any one of them, select it for your particular substrate brick, and you are able to create your brick. Okay. Now this is the view for your substrate material. Now, now we want to use the pick option, which I shown in our slide. By clicking on picks, go to the pick and pick point, edges and face. Just double click on the bottom side of your substrate. It will appear like that. A red dotted are appear in the back side of the substrate when we select for the back side of the your substrate. Okay. Then we go with the in the shape tool, then select the extrude face. This kind of pop-up is available. As I mentioned, every pop-up window help is available. So we can see the help is available in this extrude face also. When you click on this help option, it automatically give you the detail of every option available in extrude face pop-up, like name, height, use pick option, twist, taper, component, material. Detail of every option available in this extrude face window is directly appear in this help section. So you can enter the height, or we can say the in terms of thickness of your ground face, that is 2.1 mm. We enter the thickness height for the extrude for the ground face and select the material and press on OK. So it will appear like this. This is the top surface, the brown shade, the gray shade is for the grounds. Now we are going to design the patch antenna part, which is the circular shape. So we just go to the cylindrical geometric option, click on it. By pressing the escape, you are able to see the cylindrical pop-up window. You have to enter the name of the cylinder, just which direction you want to use it. Outer radius, ring, inner radius. If you want to create some ring type of structure, then enter the inner radius value. Inner radius value. If you want to create a circular disk, just enter the outer radius value. Okay. If you want to enter the some hollow cylindrical shape, ring kind of structure, pipe structure, just enter the outer radius value, inner radius value, and the height of the your cylindrical part. So we want to create only circular disk shape. So we enter the outer radius value is 23.2 and thickness for that circular patch part is 0.07, and define the new material, define the material. Which kind of material? In this case, we want to use the PEC material for our circular patch design. So this will appear like this. When axis shows the XYZ is working on the global working coordinate system. When it's appear in UVW, then it's work in the local coordinate system. Okay. Now, next step is we want to design a coaxial feed for our circular patch antenna. On the according to our geometry, we want to deploy our coaxial feed at this position, 9.2 from the center of the circular patch antenna, and the radius for that outer circle is 4, and the in for the inner circle is the 1.12. So we are going to shift our working coordinate system from origin to 9.2 in the v direction, or we can say y direction. So we are going to use the transform function of the coordinate system. This is the transform local coordinate system. If you want to move your coordinate system, we select move. If you want to rotate your working coordinate system, you select the rotate. In case of rotate system, you have to enter the values in degree. We want to move our coordinate system in v direction. V is respective to the y direction, y axis. So we just entered the values 9.2. We want to move our origin to 9.2 in v direction. So we enter this values. Now our working coordinate system move to the new origin. It's called local coordinate system. So that's why it's become UVW. Now we are going for the creation outer ring. Go to the shapes and select cylinder. Then we enter the values for the outer radius is 4 and select the material. We want to use the substrate material. That's why we select the substrate material and press OK. Now there is two options are available, because our outer ring radius is in outer structure is deal with interact with the two different materials. So we have to perform the shape interaction operation. First of all, we are going to add the both shapes, because uh, in cylindrical shape component interact with the first step is we are going to add the bow shape, and in the second part is we want to insert the outer cable. That's why we're first in the second part we insert the highlighted shape. Now we are going to, this is the steps for to cross check your designing by going to visual view in this section. You just select the visibility and wireframe. You can just cross check your design, you whatever the outer structure you prefer create, it is okay or not. So next step is create the inner circular cylinder by entering 1.2 radius and outer radius, and the height same from from bottom to 2.8. 2.1 is the ground, and the point 7 is the height of the substrate part. That's why it's 2.8 mm. Enter these values and selecting the PEC material, you can create the inner side of the coaxial feed. Now you are now you create the feeding already feed techniques. Now these are the some solver settings. First of all, we have to define the what kind of waveguide port which we want to deploy it. Just go to the pick option, select the pick, select pick edge point or face option. Double click on the back side of the circular disc part of the circular part of your coaxial feed. It's appear like this. Now just go to the macro define. Just go to the macro or just click on the waveguide port. It automatically create, this window is appear when you click on the waveguide port, and it's automatically create according to your which face you select. It's automatically create take the values for the x min, x max, x y min according to which face you select. Okay, then press the OK. These are the all default settings which is suitable for the this type of antenna. You can change it according to your need. Just press it OK. Now you are able to define the you create the waveguide port of particular design. So next go to the solver setting. You have to define the frequency range. Initially, while they creating our template, we do not enter the values for our frequency. So now we are going to enter the frequency which we want to simulate our design. We just enter the minimum and the max values for our frequency 2 and 3, and just enter the values according to your template formation. It's automatically take the default settings for your suitable default settings for your design. If you want to reduce your computation time, then change these conditions. Otherwise, no need to change any kind of boundary condition or symmetric plane conditions. It's automatically takes from your template. So these are the this is the step for defining the monitors. As we say, the second part of our results is the result monitor. So this steps belong to that part. We are defining far field monitor for at the frequency 2.4. Just go to the field monitor part in the simulation monitor and the field monitor. Select the far field and enter the frequency for the 2.4. So now we are and press the OK. So now we created we deploy one monitor at 2.4 frequency for calculating the far field. Now we want to start our simulation. Just go to the time domain solver property. Click on the time domain solver setup. This window is up. You can see that this window already. This is also according to your template. These are the all default settings. If you want to change, you can change it. Otherwise, no need to change it. Just start your solvers. After simulation, these kind of results are available. This is for the what kind of excitation signal we use for the excitation of that particular patch antenna. And these are the S parameter result for this this circular patch antenna design. We can, this is the 1D result types, which is complete results all for the compute for the all kind of simulation. These are the 2D and 3D results for the port modes and the far field monitors. You can visualize easily. These are the some far field results. So you can access these whole results by using the navigation trees. You can access this example in your CST also, or all steps are available in there. So if you have any query, just ask to us. By these are the all. I'm just searching antenna. These are the all available options for the antenna. Just first of all, download it. You are able to open its file. You can open this file also and visualize the. So this is the our design patch antenna, circular patch antenna. So if you have any query related to these steps, you can ask.
Hello.
Yes, sir.
Sir, what is the difference between waveguide port and discrete port?
Uh, yes, sir.
Or can we use any one? There is no as such improvement in the
You can
parameter.
use anyone. You can use anyone. For the better accuracy of S parameters results, we go with the waveguide ports, or according to our design, you can use any one of them. You can either go
Okay.
with the S parameter, either with the discrete port, or you can go with the waveguide ports.
Okay, sir. Okay. Thank you.
May I know your name, sir?
Yes, sir. My name is Nilesh Lakde. I am a faculty of KJ Somaya College of Engineering, Mumbai.
Okay, sir. Anything else?
Any other queries? Sir, Deepak sir.
Yes, sir.
Sir, actually, what I would like to request you is that because now, because participants are unable to see the demonstration, so if it is possible, so you can share if any video is there where actually you demonstrate the design of the patch antenna and simulating it and all those things. If you share it
We
later,
can
I will
share.
share with the participants.
Yes, sir. I will share the workflow with you. In that workflow is described every detail, every steps.
Hmm.
Why we are using that option, or why, what kind of requirement is there. Every detail is there in that particular file.
Okay, okay.
Anything else, sir? Or
yeah, that's all, sir. I think we can actually wind up.
yes.
So some of the
Thank you
participants
all.
actually are asking about the feeding of array at the single point. So what I would like to tell them is that so you can feed by using corporate feeding. So you can take a corporate feed. You can find it in any book. So with that, actually, you can divide the power and you can feed it. So it is very easy thing only. It is there from the last 50 years. It is not a new thing also.
Sir, if
So
it is planar array or linear array, we can use the corporate feed, sir. But for any shape, if you consider circular or hexagonal, for feeding such arrays, it is difficult. I am facing some more difficulty in feeding in those type of arrays.
Okay, okay.
Ma'am, you can write us a mail to regarding our problem. We will try to solve. We will try to give you some kind of documentation related to your query, or we try to share workflow regarding your query also.
Okay, sir. Thank you.
If anybody has any kind of problem related to the designing of any kind of components using CST, so write us. We will share the solution for your problem. So I think
that
everyone
is
on our email ID support@jyotimicrosystem.com. So anybody contact us.
yeah, all of you, all the participants, I request you to note down the email ID and then later you can contact the the person. So thank you so much, sir. Thank you so much for your valuable time and thank you for giving the talk. Thank you for accepting our invitation. So
Thank you, sir.
yeah, thank you so much. So I think we can proceed to the so we can actually, I think, proceed to the, I think sir gave the sufficient input about the kind of options that are available with the CST. Because all of you must be knowing the HFSS and CST both are actually competitors. You can take First of all, when you go for one simulation tool, what I would suggest you is that, so think about what are the advantages of the FTDD and think about the advantages of the FEM. So whichever is specific to your domain, so you can choose accordingly and you can go ahead with that. So this is all based on the kind of accuracy you want with the kind of application you are using. So actually both are equally capable, HFSS and CST, so you can opt for anyone. So with this, so I would like to thank Mr. Deepak sir for giving such a wonderful demonstration and the talk about the CST and its uses in different applications. So so I think with this we proceed to the uh, the valedictory session of the our 1 week workshop, international workshop on the RF and microwave components. So I would like to so Chandu sir, are you there? Dr. DS Chandu sir. Chandu sir, are you there?
Yes.
Yeah. So we are actually proceeding for the value. So we are going to start now the valedictory session. So once again, I thank all the participants for attending this workshop and make it wonderful, because without the huge number of participants like this, because I think number of participants are more than 200. So without these many participants, we can't conduct and we can't actually get that positive energy to conduct the workshop. I think the number of participants really gave us a great spirit to conduct the workshop with more positive results. So now actually I would like to request Dr. DS Chandu sir to give a overview of the workshop. So
thank you. Am I audible?
Yes, sir, you are audible.
Thank you. Good morning, all the participants. I'm very much thankful to you for your active participation for all these 5 days for the workshop. And as most of you may be aware, this is not for the first time that we are organizing this workshop. This is our third series of RF and microwave workshop on microwave components. And hopefully in the next year, we are going to plan it much bigger also. So we have received humongous applications and a very wide active participants from all over India. A quick overview of the workshop. We have received participants from 18 states of India, and since the last 5 days, we are together 18 from 18 states. We are all together sharing knowledge and learning about RF and microwave from several experts from this field. We had our opening session by Professor Shiban Kaul, who's from IIT Delhi, who has shared us a very important and a futuristic application of suspended substrate IC applications and IC designs. We also have a session by Professor Chinmoy Saha and also from Professor Devdosh Guha. And here I would like to highlight, because the last 3 workshops, and what's the difference if one could ask? The last 2 workshops and this workshop, the difference is the very active and involvement from the participants. Like generally, I used to see this kind of active participation in an offline workshop, but thanks to all the coordinators and to the participants who made such a beautiful, active and interactive sessions possible through your well structured and very insightful questions. Just as an example to hint you, Professor Guha's session was scheduled for 1 hour and it went long for 1 hour 40 minutes. And that shows the amount of interest and amount of active participation from the participants. And also thanks to all the people, all the professors, and we also have interactive sessions from the industry. Forget not, VIT AP is known for integrating the academic and industry relations. And in this front, we have also had 3 sessions. Right now, we had a session from Jyoti Electronics. Mr. Someshwar had taken a session on RF measurement from Keysight. And also, we are thankful to Dr. Satyadeep Das, who has taken us on the first session on antenna design on 5G applications and beyond. So with all this, key advancements in microwave and RF field, I hope all the participants have bagged enough knowledge to kickstart their research and to promote their research in their field. And we would be very much happy to share our knowledge as and when there is time. And you could write to us. You have the mail IDs of all the coordinators and all the speakers. So I thank you very much for attending the workshop. And this is the overview of our workshop, and looking forward for your presence once again in the next year, in the 4th version of this workshop. Thank you so much wholeheartedly. Thank you. Thank you all.
Thank you, Dr. Chandu sir, so for your nice overview about the workshop and the kind of observations you made during the things what happened during the workshop. And now I would like to request Vikas sir, are you there? Vikas sir, Dr. Vikas Vishnu sir. Okay, Shambhu sir.
Yes, sir.
Yeah, so I would like to request the Dr. Shambhu Dattananda sir to address the audience, that means participants, about the workshop.
Thank you, Bharat sir, for this opportunity. And most of all, I'll first like to thank all the participants who have been so engaging in this whole 5-day workshop. And they keep on messaging and they keep on asking the things, what to do, what to do. That is really, actually, it is very interesting and it is motivating as well that we are getting so much of response. And as a part of this workshop, I also felt very great about the institute that they have given this opportunity, and also like all the support that we wanted. And also our Dean sir has also supported Dr. Jayendra Kumar, who could not join here today's valedictory session for some other reasons. He also motivated and guided me till whatever we could have done. It is only this guidance only. And there is nothing much to say. Dr. Chandu has already discussed about all the overview and what are the key factors in this workshop. So there is nothing more to say. I just like to thank again all the participants for being so active throughout the workshop. And I really hope that it is very helpful for them. And we have taken your feedback and request for more discussion sessions with the expert or anything like that to support you in your research area and all. So we have taken that feedback and we'll try to incorporate that. And probably if we plan any specific software related or specific topic related, next time we'll try to plan it based on the discussion part more and the talk part is less. So we have taken that feedback and we'll be trying to bring that. Thank you once again, everybody. Thank you, Varas sir, for letting me to express my feelings here. We can proceed with the further session. Thank you, sir.
Thank you so much, Shambhu sir. So now I would like to take the now I would like to ask the participants about their feeling, and I want them to give a feedback on the workshop, because actually for conducting the workshop and for conducting the new workshops, so we need to know actually what actually they felt about the workshop. So that's why I request some of the participants, 4 or 5 participants, to give their feedback, so that we will actually come to know what actually happened, how they felt. So you can actually any one of the participant can raise the hand and they can start. Yeah, Prasanna sir. Prasanna Jade, sir.
Myself, Dr. Prasanna Jade from Yeshwantharam Chavan College of Engineering, Nagpur, Maharashtra. First of all, I congratulate whole team of AIT AP University to organize such a wonderful workshop, 1 week workshop on RF and microwave components. So the speakers which you really invited and it really helped us a lot because the professor like Shivan Kaur sir, then after that the session was that the Roy sir session, Bandopadhyay Roy, and then Dr. Chandu, DS Chandu. Thanks Chandu sir, you are here. I know that your SIW antenna presentation was excellent. Lot many things to learn from that. And then the Guha sir's lecture is extraordinary informative, and we are getting lot many things from that. One session I missed because of some audio disturbances, so I request you all, if possible, please share the course material as well as the presentation, PPT presentation. I know that it is difficult to share all the things, but at least presentation you can share so that we can see at our own. Because if you want to send the recording, it takes a long memory, and sometimes it may not be, it cannot possible to send it through mail also. So you keep it on the website. If it is possible, we can download from there, which is required. So this is my request from you all. And the MATLAB session was conducted by, I think, Nanda sir. That was also quite good. And so many more questions if not clear. So whenever you organize next time, so we will definitely join or participate in that particular event, and hope the from participant side also we are giving our best to understand the things, and we are cooperating. You also quite cooperative. Whenever we get some difficulty, you overcome it. Thank you, whole team of VIT University, and this is from me. Thanks for listening.
Yeah, thank you so much, Prasanna sir. And one more thing I just want to mention is that so we have this group, right? So the microwave workshop group for the participants. So we will try to keep the group just like that so that it will be useful for all the participants, because what happens is that if you want to discuss anything, if you have any doubts, you can discuss in that group also. I think in that way, that group also will help you a lot, right?
Definitely.
Yes. Yeah, I think that will be very much helpful to discuss anything. So, and if there is any jobs if anybody is doing the PhD, let us say somebody want to do the some job after the PhD. So some people, those who are actually already doing the job or something like that, they can post it there. So that way you can use the group, and any other participant who want to give the feedback on the workshop. So we want to know. I think Ranjita ma'am.
Yes, sir. Am I audible?
Yeah, you are audible.
So really, I enjoyed a lot in this session because I am in starting stage of my PhD, joining around 6 months only. After I learn this platform is very much, and I try to think more in this field. But I missed only one thing in chat box because every time I go to type WhatsApp, but after some more times after then my question is explain some researchers norms that is difficult. Sir.
Ma'am, your voice is not very clear. So can you adjust it a bit? Yeah, try to.
Now okay, was it?
Yeah, now it's
Because
okay. Speak a bit louder.
because I have some throat pain, sir. That only my voice
Oh,
is not that good, I think so.
okay.
But
Proceed,
really, I
proceed.
enjoyed that workshop and I like very much. And you are give the expression and your whatever we are asking, you are put some effort now. That is very good. to go to next level for encouraging participants. Sir. I thankful very much, and I thankful whole team also. Thank you, sir. Thank you so much for everything. Okay, but
Yeah.
kindly share the video if possible. Please kindly share videos. Sir.
Where are you from, ma'am? I just want to know where are you from?
Pondicherry, sir. I am from Pondicherry.
Okay, you are from
Pondicherry.
Pondicherry. Jade sir is from Nagpur. Any other participant who want to give the feedback? Any other participants?
Sir, good morning. This is Dr. Manish here, sir.
Good morning, sir.
Sir, this feedback is related to the FDP, right?
Yeah, FDP, sir.
Sir, regarding this FDP, actually my scholars are also attending this FDP. And sir, I don't have words to explain that how much this FDP is going to be useful for us, and the connectivity which was possible through this FDP with different researchers over and even if if I talk about me, even I came to know that many of the faculty members from VIT AP they are doing really wonderful job, and probably we can have some future collaboration, and this is only possible through the this FDP mode, sir. And I assure you that in coming years, whenever you conduct this FDP, we will be part of this FDP, because we get students. We have UG students also. We have MTech scholars also, and I have PhD scholars also along with me. So I think this FDP, which explains the basic of the technology related to the antenna field with various sections which the experts have touched over here. It's really amazing, sir. So I'm telling you again and again that I don't have words to explain that how useful it is going to this FDP will be for us in coming future. And thanks a lot for providing us such a nice platform, and giving us the opportunity to join this FDP. And hopefully we will be looking your series of FDP in coming future for sure, sir.
Thank you so much. Thank you so much for such a kind words, Manish sir. And so we can actually collaborate also. There is no problem with that. So if you have any doubts, you can post in the group. So with that, actually, we can collaborate. There is no problem.
Sir,
So
will
we
this
can write
group
the papers.
will this group active later on also?
Yes, sir. We will try to keep it as active. So I will try to discuss with Shambhu sir. Okay, so and we'll try to keep it as active, because when I was doing PhD, so we went to IIT Kharagpur, like that, IIT Kanpur. So there actually we had workshops, and we kept the group just like that even till now.
So
Okay.
that's very nice. That's very nice.
Yeah, whenever I want some help, I post in that group. So they will help me usually.
Yes, sir.
I think so. These are the
we'll keep the group active.
yes, sir. I think these are the takeaways from FDPs actually.
Yeah.
Yes,
These are the takeaways, sir, from FDP. So we get actually in normal time it is not possible us to connect, or we doesn't know which people are doing research in which area. I think this is the best mode of getting connected with each other, and I think this is the best takeaway for anyone, sir.
Yes, sir. We'll keep the group active, and it's the best thing that this group is pan India. It's not only South, West. The pan India people are here, so it will be great to have been in contact.
Very nice words, sir. Very nice words. Yeah, very nice. Sir. Thank you, sir. Thank you so much from my side. That's all from my side, sir. Thank you. And I'm really grateful to the organizers and the speakers. They were really excellent, and organizers especially. I know how much pain they have to take to conduct this FDP. And sir, one more thing. Can you provide us the recordings of all the sessions, sir?
Yes, sir. We have actually recorded all the sessions. So we can provide you all only the industry expert, those who are presented. We need to take a permission from them.
Okay,
whether
sir.
it can be circulated from. So once that is done, we'll provide, or else without industry expert talks, we'll provide all.
Okay, sir. Thank you. Thank you so much, sir.
Yeah.
Thank you. Thank you.
Okay, thank you.
I think so now let us proceed to the vote of thanks. So So I just want to mention the people behind the workshop. So Dr. Shambhu sir actually, Shambhu sir taking care of the workshop from the starting onwards, and Shambhu sir and Bapaditya Rai sir. So they got the contacts, and they got the approvals from all the speakers. So they actually planned it very well. So we were with them. And I want to thank Shambhu sir and Bapaditya Rai sir for making this workshop grand success. And I want to thank the dean of our sense, the Umakant Nanda sir, who actually gave the permissions whichever are required for us. So he is behind us throughout the workshop. So, and also I want to thank our Dean Research, Ravindra Dhuli sir, and also I want to thank the IISc Innovation Cell Director, Amit Chavan sir. And I want to thank the our main keynote speaker, the Shiban Kaul sir from IIT Delhi. He gave a fantastic lecture on the suspended substrate line based circuits and all that. So I think participants are very happy with that. Actually, the thing is that so we were using all the planar circuits nowadays. So but if you want to go for some circuits at the millimeter wave, then you need to shift. So you need to shift to another regime. So he discussed about it very well. I want to thank him very much because I listened to many of his talks. Always he surprises with his new talk. And I want to thank the Satyadeep Das sir from VVDN. So all the participants, I think, when they see so one thing I want to take away from the Satyadeep sir talk is that when you design the antennas just based on the theoretical research, that is different. But when you design the antennas for practical application, that is different. So I think with the talk from the Satyadeep sir, so I think you must have understood actually what actually happens in the industry. So it is also easy only, it is not difficult. So you can join the industry. After the PhD, you can join the industry. So his talk is amazing. So I want to thank him for his talk. And Bapaditya Rai sir gave the very fundamental talk on the evolution of the antennas. And Chandu sir, I think, gave a nice talk on the SAW antennas. So I actually want to I don't want to suggest, but I just want to give a small. It will be helpful for everyone. So those who are doing research in antennas, I think understanding of the modes, that is very important. So once the guy who understands the waveguide modes very well, he can understand anything in the electromagnetics. So first of all, understanding the modes is very important. I think the Chandu sir, I think, covered the modes part, and Devatosh Guha sir also explained the part of the modes very well. I think participants must be very happy with the modes, I think. So I thank the Devatosh Guha sir, Chandu sir for that. And also Shambhu sir, I think, gave nice talk on the MATLAB also. I think how to use the MATLAB for doing the microwave based things. So thanks Shambhu sir for that. And Shambhu sir taken all the pain and he organized the workshop. Actually, he is the central point of a workshop. He actually coordinated everything very well. And I think participants understood which component to buy and which component not to buy from the Keysight resource person talk, based on which component, which kind of equipment we have to buy for measurement. I think Someshwar Tadisetti explained it very well. He's from Keysight. Okay, so I thank him for that. And NV Rajshekhar sir explained, I think, the metamaterial based antenna design. So he explained it very well. So you must have understood what is zeroth order resonance now very well. And also I want to thank the Vikas Vishnu sir. Dr. Vikas Vishnu sir is from our department. His talk is very fundamental and very easy to understand. I think you must have gone through the Vikas Vishnu sir talk on the reconfigurable antennas. So I know that many of the participants must be unfamiliar with the way how to deal with the active devices, because active devices, in the sense diodes, transistors, how to incorporate them in the antennas. So those who want to work in the reconfigurable antennas, I think that talk is very best talk, I think. And I gave a talk on the massive MIMO antennas. I hope you followed it very well. And I thank Chinmay Saha sir. Chinmay Saha sir is always will be present in most of the shops in the India, and also he will be there in most of the conferences also. You can follow him very well. So you can take his help also easily. So I thank him very much because he is always uh, helpful for us. And also, I think participant got the best out of the HFSS session given by the Giuliano Malogni. I thank him so much for that. And also the today's talk on the CST. I thank Deepak sir from CST. So what I would suggest you is that if you have any queries, okay, if you have any queries, you can post in the groups. You can discuss there itself. Even whether we are helping or not, it doesn't matter. But you can discuss among yourself, and you can actually solve your problems through the WhatsApp group. So I thank. Apart from that, I want to thank the participants too much for this, because you gave the spirit to conduct the workshop in a positive manner. So I thank all the participants uh, for this. And finally, I just want to mention one thing. So we will share a feedback form. Okay. I think you must be knowing, whoever is conducting the workshop, the very important thing is that they need the feedback. So I send you a feedback form in the Google form. So please try to uh, all the participants, please try to fill the form. So I think with this, so I'm just ending the uh, the valedictory session. So I request all the
Sir, we can,
participants. Yeah.
can just switch on the cameras to take a photo, sir.
Yeah. So all the participants, you may switch on your cameras so that
When
we
you
will
are
take
sharing
a
the
picture of it.
participation certificate,
Yeah. Yes, I think. Yes, sir. I took the screenshot. So
Okay.
okay. So I congratulate all the participants, and so have a great day. Thank you for attending the workshop once again, and we will conduct the workshop in the next years also, and we will conduct the workshops on specific software also. So please be in touch with the group. So thank you so much.
Sir, can you share the photograph which you have taken right now?
Yeah, yes,
Yes,
sir.
sir.
I will share in the group, WhatsApp group.
Okay, sir. Okay. Thank you.
Thank you so much.